Now, I want to talk about something that we're all relatively familiar with, and that's the basic battery, okay? We know batteries, and they look something like this. Have a little nose on one end and not on the other end. This is the positive end of a battery. This is the negative end of a battery. Now, what's the job of a battery? The job of a battery is to put this into some type of circuit, and the easiest one to think about is like a flashlight, where you've got two batteries kind of positioned like this. There's some type of metallic contact here. Typically that would be a spring, so that they're kind of pushed in there. And on the other end, we have metallic contact of a light, and light shines out here because we have a battery. Okay, we have a couple batteries. Now what's happening is there is a circuit that allows the charges to run out of this battery, the positive side, out of this battery, through the little light bulb filament. So they run up here, run around, and then they have to return back and go over here. Now, why do they want to get there? Well, this is the negative end of the battery. This is the positive end of the battery. And as we talked about before, positive charges are attracted to negative charges. So they are looking for any path that they can go through and get back to that other side. So if it's sitting in air like this, well, nothing's going to happen because the battery can't get the positive charges from over here over to the negative side. But they're looking for any way to do so. If you've ever had a battery in your pocket, and I don't know why you do this, but sometimes I do. If you've ever had a battery in your pocket and a bunch of change, the change will actually jiggle around a little bit, and at some point in time, it will make enough contact between the two ends of the batteries that you can actually feel the change has heated up because it has served as a wire connecting this end to that end so that some of these charges could flow from positive to negative. Now, if we actually have a device, let me just preface this by saying the symbol for a battery is not to draw it out every time like this, but a battery is shown symbolically as being this, where the longer side is the positive side, the shorter side is the negative side. Now, battery sitting there with nothing attached to it can't do anything. But if we form, for instance, this is the way schematically what a light bulb would look like. Little charges can run out, the positive charges can run out of here, through here, and get to the negative side, and they're willing to do the work that it takes to get through that light bulb in order to get there. Now, in addition to something like a light bulb, we could also have something up here where we can store charges. And the place where we can store charges is what's called a capacitor. Now, what happens in this case, we still have positive charges over here, negative charges over here. And this is basically a pump that keeps pumping out more and more and more positive charges. And we've already discussed the fact that positive charges don't like to be together. And so, when you get a bunch of positive charges here, new one comes out, he said, boy, there's a lot of positive charges here. I'm going to run through this wire and get up to this point. Because I can. And the next one's going to run up here and get to this point. And they're going to stretch out along here rather than all accumulating right here at the battery terminal. In addition, when these positive charges run up here, over on this side of the battery, there's lots of negative charges. And those negative charges look at that and they say, you know, down here, there's a bunch of negative charges around, but up here, if I go up here, I can see positive charges across the way. Now, I can't actually get to them, but I'm still attracted to them. This is like that induction thing when I talked about before. If I bring the rod that has positive charges close to the top of the thing with the two aluminum leaves, it was enough to make some level of change there. So they can get up here fairly close. And so the negative charges come up here, same number of negative charges will come up as positive charges, and that capacitor will be charged. Now, what makes a capacitor able to be charged? Well, a couple things. Number one, how big? You can think of this not unlike a barrel that you can put water in, or a bucket you can put water in, right? You want more water? Make a bigger bucket. So if you made two really big, long plates, then there's more room on which to store charges, so more charges come up here. On this side, there'll be negatives. Okay? So that's one way you can make it bigger. Another way is if you make the difference between this side and this side bigger. So how big the voltage is between one side and another. Our typical battery is 1.5 volts. Okay? If we put 1.5 volts, it's not going to drive as many charges up there as if we have, for instance, 10 volts. Okay? That's going to be a big enough difference here that more charges are going to run up here. They're going to be able to see across this capacitor gap better because of the fact there's a bigger difference between these two. Remember when we talked about the attraction between a positive and a negative charge, we said the force of attraction between them, how far they are apart would be the R, K is a constant, and then how big is the charge? Well, these are a bunch of positive charges, a bunch of negative charges, but these charges are 10 volts different on this side and this side, as opposed to in the case of one battery where they're 1.5 volts difference. So it turns out to the measure of how much charge you can store is called the capacitance. The symbol is C, and capacitance given is the amount of charge that you can store over the difference between the two sides of the charge, so what the voltage is on that charge.